Algae are ecologically important. More than 50% of the world's oxygen comes from phytoplankton and benthic algae occurring in the ocean. Thank you, algae. This is a diagram of the short version of photosynthesis. Carbon dioxide and water are taken up by the algae. Sunlight energy is absorbed by the chlorophyll molecules, and this energy is used to split water, a liquid, to generate oxygen, a gas, and convert carbon dioxide, a gas, into sugars, a solid. The sugars, stored as starch, are the primary organic compounds from the absorbed solar energy. Algae are important photosynthetic producers of oxygen and organic material, and they are the foundation of many food chains. Most algae are photoautotrophic, which means they use sunlight for the energy to make organic compounds from carbon dioxide. Some algae are mixotrophic. This means they can use sunlight and a mixture of different carbon sources for energy, so they can both eat food and perform photosynthesis to obtain energy. A few algal species are heterotrophic. These organisms must eat to get energy and carbon. Algae are very important to us. They produce 70 to 80% of all available oxygen in the atmosphere. They produce 50% of primary production of organic material or food. They create many habitats for other living things. They even regulate the weather by releasing compounds that seed clouds and cause it to rain. Algae increase the absorption of solar energy, helping to warm the planet. This is not the same as warming caused by humans producing carbon dioxide faster than photosynthesis can remove it from the atmosphere. That is climate change. Algae are a major source of usable forms of nitrogen compounds from nitrogen-fixing cyanobacteria. Algae are also major players in the planet's nutrient cycles. The nitrogen cycle, phosphorus cycle, carbon cycle, oxygen cycle, and calcium cycles all have major algae-related components. If not for cyanobacteria and algae, oxygenic life on Earth would probably never have arisen. Algae are economically important. They are used as food additives such as carrageenan from red algae, which is used in ice cream to make it more creamy and keep the mixture from separating. Algae compounds can also be found in pharmaceuticals. There are several compounds produced in algae that have great promise in treating human disease. They are also in cosmetics. The natural cosmetics industry has been using algal compounds for years in products focused on skincare. Many types of algae are used as food for humans and livestock. In fact, algae are among the most nutritious food sources that we have. Humans have been consuming algae as food for at least 5,000 years, perhaps longer. And algae are now being used in biotechnology. Single-celled algae are very useful as biological factories to produce many needed biochemicals. Algae are also very good at removing nutrients from seawater, freshwater, and human-produced wastewaters. These captured nutrients can be used as fertilizers in agriculture. In addition to food applications, oils from algae are good for the production of biofuels. Algae can serve as the feedstock for several different biofuels, including biodiesel, bioalcohols, biocrude, biomethane, and biojet for aviation fuel and biohydrogen. Seaweed products and extracts are used for a variety of human and animal uses. The ecosystem provided by seaweeds are valued at billions of US dollars and include habitat formation, support of fisheries, coastal protection, specifically by kelp forests against wave action, and the previously described nutrient cycling and extraction. Sunlight and carbon dioxide from industrial processes, along with wastewater for nutrients, can be used to grow algae in massive open raceway ponds. The algae are harvested and the molecules of interest are extracted. Currently, the extraction of algal oil is not economically competitive with petroleum, but it is viable for cooking oils. Algae can be converted to biocrude by hydrothermal liquefaction, a process that treats the algae at high temperature and pressure to convert the molecules to a crude, oil-like liquid. The collected feedstock material may be converted to biofuels, which include drop-in replacements for jet fuel replaced by biojet, gasoline replaced by biobutanol, and diesel replaced by biodiesel. This is an idealized representation of the algae-based fuel process. Other common products from algae include diatomaceous earth made from diatom skeletons or shells called frustules that are made of silicon dioxide or glass. Diatomaceous earth is used for filtration, polishes, and as an environmentally friendly pest control. Phycocolloids are compounds derived from macroalgae or seaweeds that are used as thickeners and stabilizers in food, cosmetics, and other commercial products. Examples of phycocolloids include carrageenan, alginates, and agar. As an example, in 2004, CSIRO, Australia's science agency, calculated that the world's jet fleet used 322 billion liters or 85 billion gallons of Jet A fuel. To replace this Jet A fuel with biojet made from soybean oil, we would have to cover an area the size of the entire continent of Europe with soybeans to get enough feedstock. Alternatively, we could cover Belgium with algae ponds and produce the same amount of feedstock oil to make biojet fuel. Algae can also cause problems. Excess nutrients can cause algal blooms, where algae grow to very high concentrations, changing the color of the water. And certain algae may cause red tides. Some bloom-forming algae, for example dinoflagellates and cyanobacteria, produce potent toxins. These toxins can cause shellfish poisoning, fish kill events, as well as human health issues like liver disease and central nervous system damage. Algae can biofoul ships, costing significant amounts of money to clean, and they can also foul commercially important bivalves, making them unmarketable. Shellfish are filter feeders and may accumulate toxins produced by cyanobacteria, diatoms, and dinoflagellates. Shellfish poisoning includes 4 syndromes which are primarily associated with bivalve mollusks, including oysters and clams. The toxins responsible for most shellfish poisonings are very stable, and ordinary cooking methods will not eliminate them. The rule of thumb is, if a shellfish is closed after boiling, do not open it or eat it. Amnesiac shellfish poisoning is caused by consumption of the toxin domoic acid. This toxin is produced naturally by marine diatoms belonging to the genus Pseudonychia. Diuretic shellfish poisoning, as the name suggests, manifests as severe abdominal pains and intense diarrhea that is caused by the toxin okadaic acid. Okadaic acid is produced by the dinoflagellate Dinophysis. Neurotoxic shellfish poisoning is caused by the consumption of brevetoxins and related compounds. Brevetoxins are neurotoxins produced by the dinoflagellate Caronia brevis. Lastly, paralytic shellfish poisoning is associated with bivalve mollusks that accumulate neurotoxins, chiefly saxitoxins. Saxitoxins are a family of toxins produced by various dinoflagellates, diatoms, and cyanobacteria. Saxitoxins are some of the most potent toxins known. There are greater than 60 different types described. The 2008 Summer Olympic Games saw a bloom of Ulva prolifera, a type of green alga. This huge example of eutrophication is caused by nutrient-rich runoff from agriculture and untreated sewage. The People's Liberation Army spent an entire month cleaning the beaches before the Olympics started. This bloom has occurred every year since, although this could be a novel way to keep soldiers fit. The take-home from all of this is that Algae have significant impacts on the global ecosystem in both positive and negative fashions. These impacts are very important for human life and civilization.